Buddy, we're going
Good
to
morning
wait
and
just a
welcome
couple.
to our seminar.
Going to wait a couple minutes, make sure we got everybody here.
Well, we want to welcome everybody to our webinar on fall protection. My name is Tim Peterson. I'm the Vice President of OECS. Dan Dustin is going to be your main presenter. Dan has many, many years of experience in the construction industry and is one of what we consider the key experts in fall protection in the Midwest. So if there's any questions throughout our presentation, please use chat to jump in and get that question out right away. We'll respond as quickly as possible. And those of you that are part of the webinar, if you have any general industry questions as it pertains to fall protection, please ask us those too. We can help with that, even though the webinar is focused towards construction. We can also interject and take care of anything that falls within the general industry side. So with that, Dan, I'm going to turn it over to you and we'll jump in as need be. Thank you.
All right. So the topic for today is fall protection, and what we'll be looking at is when, where, and how to use fall protection. Let's look at some statistics to get started. I know everybody loves statistics. When we look at the construction injury and fatalities within that industry, the leading cause of construction fatalities among workers 45 years old and older is falls. Now, up until a couple of years ago, it was the leading cause of death among all construction workers. And one of the things that I point out, particularly for those that are a little more mature, shall we say, is the reason that it still is the leading cause of death for people over 45 years old is that our reaction time slows down. You are far more likely to not be able to prevent a fall once it starts because you don't react quickly enough. Almost 400 workers die annually from falls, and more than 200,000 are injured. The part of the problem here is that a large number of these workers are out for 90 days or more. And they know from sad experience that typically when people are out of work that long, particularly on a work-related injury, that they may not go back to their normal occupation. So lack of fall protection is the most often cited OSHA violation. So when we look at the causes of death from falls, if you look at my graphic here, what you're going to see is that about 31% or close to a third of those falls occur from the roof. And when we look at the next leading one, it would be falls from ladders. Then we look at scaffolding, and then we start getting into some of the smaller ones like falling off a non-moving vehicle. And in the example that we've got here, you can see a worker standing on the forks of a telehandler at height. I'm sure if we were to do a poll of the people that are on this call, you've all had an opportunity to see this one. There are ways this can be done safely, but what you see here is not one of them.
Hey, Dan, on that roof arrow, 31%, that's just not on high roofs. That's roofs of any type. Is that correct?
That's roofs of any type. Correct. When we look at the falls to lower level, from a working level, about 6%. And when we look at girders and structural steel, we're looking only about 7%. Now, I've sort of picked on iron workers for years because iron workers do get a little bit of leeway in their fall protection requirements. And they really are not the leaders in the people that fall. What I did find interesting when you really look into the statistics is to find out that people that fall on the same level upon which they're working account for 5% of those fall deaths. So you don't have to fall from the roof. You can fall working on the same level that you're on and be killed doing it. What we're hoping to accomplish here is to get people to recognize fall hazards and begin to make the identification early on, prior to the time we actually plan out the work, to make sure that we're identifying that the work we're about to do represents a fall hazard, to use basic fall protection systems, and to prevent objects from falling while you're working at elevation. We'll also discuss briefly inspecting personal fall arrest systems, and we will also discuss the requirements for having a rescue plan in place during the time that the work is actually taking place. So keep in mind that, as Tim pointed out, we're focusing on construction, and there are some differences. When is fall protection needed? Well, there's a difference between general industry and construction. Construction, you are exposed to a fall hazard at 6 feet or more above the next lower level. You are required to address fall protection systems. In general industry, that number is reduced to 4 feet. And part of the reason is that there's considerably more work performed by construction workers at elevation, and they allowed that extra couple of feet because there is so much work performed at elevations of 6 feet. I'm required to have fall protection also if there is the danger of falling into or onto dangerous equipment. And this is also true in general industry. Or if there is a possibility that tools and equipment could fall onto workers. In other words, anything that we're actually using to perform the task or the materials involved. So when we discuss employer requirements, keep in mind we're talking about the hierarchy of what OSHA actually considers. And when we look at an OSHA standard, whether it's general industry or construction, we're looking at a minimum guideline. So what you see is that I have some requirements under OSHA, but the host employer, for example, if I am a contractor working in an existing facility, they may have additional requirements.
Well, how does that employer really define, Dan? I mean, is it just the owner of the contract? Is it the general manager? Is it the CM? Where does that really fall into when you look at the employer? How detailed or how specific does that break down?
Well, using my own experience as an example, I worked for a major commercial contractor, as a general contractor, as a district safety manager. And during my tenure there, we very often had our subcontractors held responsible to comply with our fall protection requirements. So when you evaluate a subcontractor that's going to come in to work for you, then you want to look at what their fall protection requirements look like. And if you feel that yours are a better protection for the workers on site, you can require them to use yours. So essentially, it is the strictest set of rules that applies on the site, whether it's a construction management firm or the owner's representative. You need to find out who has the strictest set of rules and whether or not they expect you to comply with their rules. So part of that is looking at the fall hazards that are associated with the facility that you're working in and the work that you're there to do, and the methods that are used to protect you from those hazards. In a lot of cases, it may be that there's passive means of protection in place already, and there'll be no additional requirements. We're going to talk about that when we get a little further down. Second thing then is that we have to look at the proper and safe use of personal fall arrest or fall restraint systems. Is it possible to install them and use them incorrectly? Absolutely. And if you'd care to see examples, I'm sure between Tim and I, we could provide you with several hundred pictures of fall protection systems, not only incorrectly installed, but certainly incorrectly used. The other one is that we develop safe work procedures. When we look at the work that we're going to do, we can often address the fall protection required by eliminating the hazard. If I can eliminate the hazards of working at height, I eliminate the requirement for having a fall arrest system. So common fall hazards that we would find. And keep in mind that we're looking at both construction and we're looking at general industry examples here. The edges of platforms, runways, and stairs are good examples. Sloping, walking, and working surfaces. In other words, if I can slide off the edge, I have to address the fall protection standard as well. Floor and wall openings. If there's a danger of falling through an opening in a wall or through an opening in the floor. Tanker and hopper trucks or rail cars also have requirements for working at elevation where I need to be tied off, and there are systems available for that. And then when I look at things like service and elevator pits, in fact, the state of Minnesota has got a couple of rules that apply. One of them is that any pit or shaft is considered a confined space. And if it's more than 5 feet in depth and somebody's going to be working in it, I have to have a mechanical means of retrieval available. They have to be protected from falling in the first place. And I also have to be able to get them out if they get in.
And is there a difference on the vertical wall versus a horizontal truss system when it comes to that fall hazard issue?
There is, when I'm looking at floor or wall opening, depends on how big the opening is itself. Essentially, under the construction standard, it says that any floor opening greater than 2 inches in the least dimension has to be covered or otherwise protected. Obviously, I'm not in danger of falling through a 2-inch hole, but it is possible to drop a tool or equipment through that hole and injure someone working below you. In the case of a wall opening, any opening that is 18 by 30 inches, that the lower edge is 39 inches or less above the floor, requires fall protection over the opening as well. So if you look at the picture of the gentleman doing the framing, he has an unprotected window opening where it looks to be about 16 inches between the surface he's standing on and that opening in the wall. That would require the fall protection.
Thank you.
There is a hierarchy of fall protection controls. And the number one thing that we would ideally love to do is eliminate the hazard completely. Now, if you look at the example that's shown on the screen, the gentleman is replacing light bulbs from the ground. He doesn't even have to have a ladder to do it. Obviously, the safest way to do this job is never to have to work at height. Then we start looking at passive fall protection systems, and these go from the most effective to the least effective as we move to the right. Passive fall protection systems are those systems that don't require any intervention by the people that are actually working there in order to remain safe. So this is the system that's considered early on during a construction project, where they look at the potential fall hazards and decide where they're going to have to put up passive fall protection systems. Then we look at fall restraint systems. And once we get into fall restraint and then into fall arrest, we're looking at very specific requirements for the person that's being protected to actually do something to protect themselves. When we look at hazard elimination and passive fall protection, the systems are in place already, and I don't have to consider how I'm going to protect myself. The guardrail's already up. With a fall restraint system, I have to don a harness, and I have to ensure that my system is set up so that I cannot fall off the edge. I can reach the edge to work, or I can reach the opening to work, but I can't go past that opening to fall. Fall arrest systems, on the other hand, are where I can't set up a passive fall restraint system. I may have to work right out at the point where the potential is there for me to fall. And this kind of goes back to what you were talking about, Tim, with where they're walking the joists and they have to be tied off, because it would be very easy to step between those joists and fall. And I have to have a fall protection system designed to stop me from hitting the floor if that happens. There are some substantial additional requirements that we'll discuss for fall restraint and fall arrest systems. The last one is administrative controls. And those of you in construction are very familiar with these. A warning line on the roof for the roofers is a good example of an administrative control. Essentially, it provides no actual fall protection. The administrative control is that I have to train people that if they work beyond my warning line, that they must be tied off to prevent them from falling.
In which situations is that administrative control justified, if I can use that word? Because it's not a catch-all.
It is not a catch-all. The other thing is that where that warning line goes depends on the task that's being performed and the people that set it up. I can establish a warning line for roofers at 6 feet from the leading edge of the work. In other words, if they can reach the edge of the roof, I have to put my warning line at 6 feet back from that edge. Anyone else going out on that roof to perform work has to have their warning line at 15 feet from the edge. This is again another place where OSHA recognizes that the roofers have to operate closer to the edge. And the level of compliance and training that's expected from those people is significantly higher. The other thing is when I'm looking at leading edge work, for example, I have the iron workers laying decking on bar joists that they've already put down. Or I've got precast guys that are setting precast planking. They're allowed to work within a controlled access zone. And the requirements depend on which job you're working. In the case of precast concrete guys, they're allowed 60 feet or half the length of the panel that they're setting. And the reason for that one is pretty obvious. If somebody manages to drop a precast panel, those guys have to be able to get away from it as it falls. So here's a great example of the gentleman changing light bulbs from the ground. He is not exposed to any fall hazard at all during this. Now, if I did have a concern here, it wouldn't be fall protection. The only other thing I might address on this one is electrical safety. Guardrail systems. A standard guardrail system consists of a top rail, a mid rail, and vertical supports or posts to hold that system in place. There are very specific requirements for this as well. The height from the upper surface of the top rail to the walking and working surface is 42 inches plus or minus 3 inches. It has to be able to withstand 200 pounds of force in an out or down direction without deflecting below that 39 inches, the minimum. Mid-rail splits the difference between the top rail and the working level. And if the system requires a toe board because of the danger of dropping materials or tools, then I have to have a nominal 3.5 inch height, and it has to be mounted so that there is no more than 1/4 inch of clearance above the floor.
You stated that the toe board, if required, so there's our options out there where the toe board is not needed.
There would be spaces where there is not a requirement to have a toe board. For example, when I put a guardrail system up to protect scaffolding, I don't necessarily have to have a toe board to prevent dropped objects as long as the area below the scaffolding is protected and nobody can get in below it. So when I'm performing work at height, if I can protect the people that could inadvertently walk in below by barricading the area, you kind of obviate the need for that. But our recommendation is you always put a toe board up if the potential is there to drop stuff.
And as far as what that guardrail system be made of, it's pretty open-ended as far as that, as long as it meets the requirements that you just stated.
It needs to be construction grade lumber, or in this case, we actually see an engineered system where they've got welded handrail in this case. There's a couple of things to keep in mind. I can't have more than 96 inches, 8 feet between the uprights. And if I'm using construction grade lumber, I can't do my splices on the top or mid rail between the uprights. The splices have to be made at the vertical supports.
Right.
Another example of passive fall protection is where I put physical barriers up in some cases. And if you look at the picture that's on the screen now, we obviously have a large warehouse operation because you can see the roll-up doors on the other side as well. And just for air movement, they've got these doors open. But in order to prevent people from inadvertently stepping off that edge, they've put yellow plastic chain across there as a visual indication. But I have seen hard systems such as fences or scissors gates that they can put across these, or in some cases there are actually pull down additional doors such as screens that they can pull down over these that prevent you from walking off the edge as well. If they have to actually stop a forklift from going off, they put what they call a belly band in there that looks like a 6-inch wide nylon band that's securely anchored to the doorposts on both sides and would prevent you from inadvertently backing off the edge with a forklift. Okay, again, passive fall protection systems. When I have openings in the floor, I have to prevent surface penetration by the work that's going on above. When I am looking at how I'm going to cover these holes, keep in mind that I have to have something that's designed to support twice the intended load of people or equipment. So in this case, you can see that they have a piece of steel plate, what we call trench plate. Obviously, they're anticipating a heavy load. When I look at standard construction, what we often find is 3/4 inch plywood covering these holes. And when I consider the potential traffic, keep in mind that a 20-foot scissors lift, 32 inches wide, weighs in at well over a ton, and 3/4 inch plywood will not be enough. So if I'm intending to drive equipment or materials over those openings, I have to have sufficient protection to keep from going through the cover.
Those of you that are crossover in general industry and stuff, this requirement also falls under there for protecting out floor openings and having them secured and marked with the word hole.
Yep, they have to be secured to prevent displacement. Unfortunately, all too often, people will put down a cover. They won't mark it. They know the hole is there, and somebody else will come and take that piece of plywood to use it for something else. And now I've got an open hole in the floor. So they have to be secured against movement, and they have to be marked as hole or cover in a contrasting color to make it obvious what they're there for. Fall restraint system. In this case, you can see the worker is working right out at the edge, and I don't know how clearly you can see it, but I'm sure that he would prefer not to fall off that end. What we've got along this outside edge is lightning rods, and they come up to a pretty sharp point. Rest assured, he would prefer to work at the edge and not take any chance of falling over that edge. What we have here is a positioning anchor that allows him to work from a tie-off in the center and work right along that edge without fear of falling off the edge. He can't reach the edge. We move from that into a personal fall arrest system. These systems are designed to stop a body that has managed to get off the edge and they have fallen from the working level. There are some design criteria for these that are very important, and it becomes more obvious when you find out why it's important. The big one is it has to limit the maximum arresting force on my body to 1,800 pounds or less. And when you consider that if you are 6 feet tall and you weigh 200 pounds, if I don't have a system designed to limit my fall forces and I just stop at the end of a 6-foot fall, you will generate 4,000 pounds of fall force, actually a little bit over, about 4,400. So these systems are actually designed to arrest that fall within a distance of 3.5 feet. And it has to be engineered so that I can prevent contact with the lower level or not strike anything sticking out on the way down. So that's another consideration when I am looking at these systems, is when I consider my fall protection system, look and make sure that it's not just hitting the next lower level, but that I can't hit anything sticking out on the way down as well.
Dan, you used the word engineered. Can you explain that a little bit more?
Actually, we're going to get into it when we get into the next slide, because we're going to, not quite, 2 slides. When we get into talking about what I can tie off to.
Perfect.
There are pre-engineered systems that I can buy where I only have to worry about what I connect it to. And there are engineered systems where a registered engineer will look at the structure itself and give you very specific rules about what you can tie off to and what it has to be rated for. Okay, the other big thing is that any system that I'm using for personal fall arrest has got to be set up to withstand twice the anticipated impact force. Now, the good news is that I believe about 95% of the harnesses that are on the market now limit the maximum fall arresting forces to 900 pounds, which still sounds like a lot, but believe me, if you're going to hit the end of that fall protection system, 900 pounds doesn't hurt near as bad as 1,800 pounds does. So personal fall arrest systems, they use the ABCs to describe a personal fall arrest system. The first one being the anchorage, that is, what am I tying off to that's going to catch me if I fall? The second is a body harness. And the third is the components that connect the two. And there are a number of different types of components out there: snap hooks or D-rings, the connection points, carabiners, lanyards, deceleration devices that are available, lifelines, self-retracting lifelines. Big thing with these is they have to be installed, used, and maintained according to manufacturer. One other thing to consider is the recommendation, and if you talk to any of the manufacturers, they will tell you to buy all of your components from one source if you can, because if there's a failure in the system, it's easier if I work with one provider of the equipment than having to go back and figure out which link failed.
As you look in this picture, this is a general industry situation. This is an order picker.
Yep.
And fall protection is required in that because he or she to not be protected with any type of a guardrail perimeter around that landing. And so those of you that work in general industry or cross over into both sides of it, realize that fall protection does affect in a lot of different ways. And in this situation that Dan has a picture of, it's definitely a very obvious one.
Now we'll talk about the anchorage. The anchorage is the secure point of attachment for your lifeline, lanyard, or the deceleration device to slow you down. If these systems are not engineered, that is, I don't have a PE that comes in and designates the places that you can tie off, then it has to be able to withstand 5,000 pounds of force per worker attached to the system. So in the case of the pre-engineered systems, typically they're set up, DBI Sala or Miller or some of the other systems, they're set up so that I can attach 2 workers to the system. Many of them are made of rope or webbing, and they are designed to be connected between 2 anchors and then tensioned properly so that they will arrest a fall by one or both workers. So if I have an engineered system, I'm allowed to drop that to 3,000 pounds.
Does that engineered have to be by a certified, licensed, or qualified engineer? How does that, can anybody design an engineered system, in other words?
No, engineered means engineered, and I've got to have a PE stamp on the engineering drawings that indicate it. Okay, ideally, we would pick an anchor point that's above us. This is not always possible. It's not always feasible, but the idea is that we limit the amount of free fall before we begin to activate that system. So if I've got my anchor point at or above my shoulders, I'm not going to fall nearly as far before it activates. If I'm 6 feet tall and that anchor point is at my feet, I have my full height plus that 6-foot lanyard plus my deceleration device. So I've got to have significantly more space below me. If you're not sure about anchor points, I can tell you the advice I've been giving for years, and this includes firefighters when they're doing high angle rescue work. That is, if I look at something and it's structural, ask yourself, if that wasn't there, would the building stand up? The other thing is, when you're looking at anchor points, look at it and evaluate whether or not you think you could hang your half-ton pickup from it. If you can't hang your half-ton pickup from it, it's probably not rated for 5,000 pounds. Okay, that's just a quick rule of thumb. So I want something substantial. Remember the amount of impact force you generate when you hit the end of that lanyard. Okay, next one is the body harness. This is known as a class 3 body harness because it wraps both the pelvis and the torso and is designed to evenly distribute the arresting force of the fall across all of those straps if it's worn correctly. In this case, I got to give the guy credit. He actually has the shoulder ring where it should be, up between his shoulder blades. One of the things to be aware of is this ring will slide. They allow for 1 foot of slide, although I've seen a lot more than a foot if I don't have it on properly. They can also be used both for positioning or for suspension. There are certain harnesses that you can actually hang suspended from to perform work, but I have to have the proper harness and the proper equipment to distribute the weight.
Dan, I was told a statement once that a body harness worn incorrectly is more dangerous than not wearing a body harness at all.
It actually is because of the damage that it can do to you. If you look at the bottom of the picture, right alongside his pockets on either side, you can see that he has a lot of slack in the leg straps on this. And definitely an issue for anybody that hits the end of this, although I think males will probably find it somewhat more painful because typically those leg straps will turn and they will catch you in the groin. and you will arrest your fall on a part of your body you'd rather not land on. For those of you who have been around long enough to remember when body belts were part of a fall arrest system, they are not considered part of an arrest system since 1998. In fact, you can't legally use them for fall arrest. They had a nickname for those. They call them backbreakers for a reason. They can be used for positioning. Now I've got to be able to connect that body harness to my anchor. What am I going to use? Well, what am I expecting? What do I have to hook off to? Connectors are designed to attach the lanyard to the anchor in the harness. Big thing with these is, particularly if you have any older equipment, make sure that the snap hooks lock. It has to require two separate motions to open the hook. One is to release the lock, the other is to open the hook. If you look at the picture that's X'd out here, you can see these are non-locking hooks, and these were very common. As far as my connectors go, all of these connections are designed to be used one connection. In other words, I'll never put more than one snap hook on that D ring in the back. They do make attachments for some of these harnesses that will give you a second anchor point, but I should never have more than one snap hook or carabiner hooked to the back of that harness. I also don't want to connect my snap hooks directly to webbing a rope. I don't want to hook two snap hooks together. Part of the reason for not connecting my snap hooks together is that I will point load them if I fall. Many of these are drop forwards. They're incredibly hard and tough. They will take a massive load, but if I point load them, when I fall on them, you may very well break one of them off. Never attach to a D-ring with another snap hook or carabiner attached. They do not get tied directly into a horizontal lifeline. Anytime I'm using an engineered system, I will be using a carabiner or a rigging ring to attach to that system. You will never attach a standard snap hook directly to a horizontal lifeline. Last one is that I don't attach them to objects that are incompatible in shape or dimension. If I go back and I look at this one, which they call a pelican hook, I can get this around a 2-inch angle iron handrail. However, it is not a compatible shape. If I were to fall on it, it will point load the hook at the point where it contacts one of the corners on the angle iron. Now, if I was tying this off on a welded steel handrail, that's a little different story. That's compatible in shape and size. We'll talk a little bit about this, but just so you're aware of it, what you see in the picture just adjacent to the hook on either side with the line of white stitching, that's a fall arrest indicator for that harness. If someone falls on this harness, it will pull that white stitching loose. So this is part of our inspection. We'll talk a little bit about that when we're talking about the inspection criteria later, but this is, I think, the only picture that actually shows it. All right, the lanyard is a flexible line with a connector that connects the harness to the anchor. Very often these contain your deceleration device. Okay, in this particular case, this was an elongation or a bungee type. If I fall on this, it will arrest my fall by essentially stretching out. You can see that it's bunched up, okay? With these, and this is true of any synthetic, I absolutely don't want to tie any knots in these. And if I'm wrapping it over something, make sure that if it has to go around or over a sharp object, that you're patting that corner heavily to prevent from cutting or damaging these. This is the system I was talking about where he's connected through a carabiner directly to a wire rope horizontal lifeline here. And this is actually not the anchor right here. All this is a support. If he's moving freely along this, their carabiner can be slid directly through this and you can walk from end to end on this system. Typically a system like this will be rated for at least 2 people. Although in this case, it looks like we've got at least 5 1/8-inch steel cable. It might be rated for significantly more than that. So Lifeline connects a personal fall arrest system to the anchor itself. So in this case, I would have an anchor at either end of this, and this would be tensioned.
Dan, what's the minimum diameter cable allowed for this Lifeline?
Depends on the manufacturer, but there is, typically, I'm not going to see anything less than 1/2 inch. I don't think I've ever seen one less than 1/2 inch. Now, what you may find is that you will have guardrails run around a perimeter. For example, the iron workers have put up their cable guardrails around a perimeter of floor. And if they leave the site and sign over that guardrail system, that can be smaller than the fall protection, the fall arrest anchor, because it's not designed to be used as a fall arrest. It only has to withstand 200 pounds. So vertical, if I am working from a fixed point, I may have a vertical where I'm tied off to one and it hangs off the side of the building. A good example would be workers working on a swing stage. In addition to the supports for the swing stage itself or the suspended scaffold, they have to have a separate lifeline to a separate anchor for each worker on that scaffold. All right, deceleration device is designed to dissipate the energy that builds very, very rapidly during a fall. There are several types out there. Rip stitch, tearing, or stretching lanyards are the most common. You may hear people refer to a rip stitch lanyard as a screamer for a couple of reasons. One is they're sewn into a Z configuration. And if you hit it hard enough to tear the stitching, it makes sort of a screeching noise when it tears the stitching out. Of course, the other part of that is the sound you make when you fall, and that arrests your fall. They make rope grab devices. These are commonly used for single anchor point vertical lifelines. Essentially, I have to adjust my rope grab as I'm moving up or down to make sure that I can't free fall any significant distance. This would be particularly true when you get on the swing stage at ground level and go up the side of the building. If I don't keep my rope grab sliding up that lifeline, I could conceivably still be anchored at the ground. And when I fall, I could hit the ground.
And can a general contractor or an owner make certain requirements of what they will or will not allow for fall protection on a job site?
They absolutely can. I can tell you that some of the general contractors in town actually require fall protection to be used when you're working in the scissors lift. And the standard does not require fall protection in the scissors lift. But for those GCs or construction management firms that do require it, you have to wear it.
How about the idea of rope grabs versus lanyards versus retractables and such? Can there be a push shove on that?
There can be a push shove on that. They can tell you what they prefer not to see on their site. They may not, it's like contractors that tell you they don't want any aluminum ladders on their site. It's their site. You're there as a guest worker or a subcontractor to them.
Okay.
Well, typically those things are ironed out prior to the time that the workers actually arrive on site. The last one is self-retracting lifelines or lanyards. And I might be prejudiced, but I find that this is certainly my preferred method. And there's a couple of reasons for that. One of them is you can't gain enough speed to fall very far. These have an inertial or centrifugal brake in them that breaks very, very quickly. In fact, one of the primary complaints is that if I am using them on a horizontal surface, you have to walk at a moderate pace, because if I try and walk too quickly, they will lock up. Okay, inspections, and this is the user inspection. Like many of the other standards, there are requirements for competent person in fall protection. And one of the things that many people don't understand about, when they gave me a harness, so I know how to put the harness on, okay, but nobody trained me how to inspect it. Well, then you're not competent person for that harness. Considering as the user, you are expected to inspect that harness prior to the time you put it on every day, you become the competent person after you have been trained on that harness. They tell you what to look for. So it's inspected before every use. If you take it out of the job box or it just came out from the tool room at your company, take a look at it. And one of the things that we find commonly is that somebody did fall on it, and those indicators that I showed you in that previous picture have been popped. And that's something very easy to miss on a visual inspection.
And on an inspection, can a contractor or a company assign one competent person to inspect all their harnesses, or should it be the person wearing it?
Well, it's both, because they're also required to do quarterly and annual inspections on these. When you buy a harness, and I don't care if you get the $85 Walmart special or if you get a $600 harness from DBI Sala, there is a serial number assigned to that harness, and you're expected to have proof of inspection for those on a quarterly and annual basis. And that competent person is usually the person that runs the tool room or the warehouse.
So how do I, as a competent person, really look at this? And you're jumping a little bit on my part, but what is considered defective versus just normal wear and tear?
Well, let's take a look. When I look at the D-ring attachments on here, one of the things I'm looking for is significant mechanical damage to it. Either I'm seeing a lot of wear, although they're very, very hard and you often are not going to see wear. What you will see is corrosion on these. And as they start to corrode, if they have significant pitting or corrosion on them, they should be removed from service. Where does that take place? Well, if I've got block layers or cement guys that are wearing these and working at height, one of the things they have to be aware of is that concrete is corrosive and it will attack the metal fittings on these. So I'm looking for dings or gouges, visible cracks in these. When I go to look at ropes, you know, my attachment points, or if I'm looking at the straps, what I'm looking for is that they're not cut or excessively frayed. Now, what you will see is that they get fuzzy, and we actually call that caterpillaring. That's not a significant issue unless they're significant. And when they start to look like they're furry, that's a little different than if they just have some light surface wear on them. The other thing is, if I have any cuts or tears in these, they have to be taken out of service. And we also inspect the stitching, make sure that I don't have pop stitching on these. The integrity of the harness is inherent in the way the harness is built. And the minute that I have stitching failing, or if I'm finding damage such as evidence of weld spatter or chemicals, paints, sealants, coatings, chemical attack on the webbing itself, those have to be removed from service. If you have the type of harness that has tongue and buckle leg straps on it, take a close look at where the tongue goes through the eyelets in the leg strap. If somebody falls on these, it will stretch those soft brass eyelets and they get stretched into a football shape. That's another indication that somebody may have fallen on that harness. For the parts that are supposed to move, ensure that they move freely. And this includes your snap hooks, your carabiners, anything on that harness that is designed to move should move freely, anything in the system. When I have defective components, remove them from service immediately. Don't say I'll get a couple more days out of it, because if you do fall on it, the potential is there for it to fail. The other thing to remember is if somebody does fall while they're suspended from a harness, all of the components in that fall arrest system have to be taken immediately out of service. That means the lifeline, the connecting system, and the harness itself. All of that's got to be removed. Rescue plan. Rescue plan has got to be in place before anybody is put into a position where they could fall. What we're looking at is rescue in the shortest time possible. Ideally, we'd like to see it immediately. The issue, of course, is when I am sitting in that harness and I've got the pressure from the leg straps on the femoral arteries in my groin, I am reducing the blood flow back to the brain because it pools in your lower extremities. Most of the newer harnesses come with suspension trauma straps. For those that don't, they are available as an add-on to most of the harnesses. What this allows me to do is create a step where I can stand up and take my weight off of my groin and onto the shoulder ring in the back. It distributes the weight a little more evenly. If I don't have suspension trauma straps, there are ways to keep the blood moving while you're waiting for rescue. Pushing your legs against an object, for example, you're hanging off the side of a structure, you can push against the wall and keep flexing your legs to keep the blood moving back up into your torso. You can raise and lower your legs if you're hanging freely and can't touch anything. Just raise and lower your legs. 911 is not a rescue plan. I have to have a rescue plan in place that allows me to use existing resources wherever possible. So it may be that I've got a lift available that I can reach them, or I can get a ladder up under them. If I have to rely on 911, you need to make very, very certain that the fire department is capable of performing high angle rescue. There are a lot of them that don't.
Who has to write this rescue plan, and what qualifications does that individual have to develop or write that rescue plan, Dan?
That's your competent person. And your competent person, if you look at the description of a competent person, recognizes the potential hazards and has the authority to fix them. So they have to have an understanding of the hazard involved in suspension trauma and be able to look at the materials and equipment that they have available and say, what do we have here that we can get up under somebody to get their weight off that harness as quickly as possible?
If OSHA shows up on a job site, is there a chance that they may be asking to see that rescue plan?
They may very well. It should be part of the site-specific safety plan.
Okay. And if I'm a subcontractor and I provide the general contractor my rescue plan, can that general contractor decline and say that's not adequate? Do they have input on that part?
They do. If anytime the construction management firm, the owner's rep, anytime that they feel that the safety measures that you have in place are inadequate, they can in fact tell you that they'd like to see more. And this is part of what we deal with as consultants is helping some of these companies work through the stuff like that, where they've been told, hey, we were told this isn't adequate. Well, when I look at it and I find it's not, then I'll help you make it adequate. All right, fall prevention. Now we're looking at administrative controls. Believe it or not, housekeeping is a significant factor here. A lot of falls to the same level occur because of poor housekeeping. If I'm performing overhead work, a pretty simple administrative control is to not start the work until I have the area below barricaded. Look and listen, pay attention to what's going on. I've got to believe that some of you have walked out of a building under construction only to see him swinging a load over your head with the potane or the overhead crane, the tower crane. You know, look and listen, pay attention. Use fall protection anytime it's needed. And if you look at the example in the picture, I have a wide open stairwell with no stairs. No, there's no fall protection here at all. This should have been addressed as soon as that opening was created. Avoid dropping objects. Tim can tell you, and we both were there, if you worked down at the Viking Stadium under construction, you had to have pretty much everything tethered to you if you got up into the upper steelwork at all. The other thing is avoid running if you possibly can. I mean, I realize in an emergency situation, people tend to want to run, but don't run. It creates an almost immediate tripping hazard.
What about site-specific stuff, Dan? Is there such a thing as non-preventional, non-capable, and you got to do something that's quote site-specific?
There is I won't say loophole is not the right word. The proviso is in the standard that says if fall protection is infeasible, but in order to be considered infeasible, the company that has the people that are at risk has got to be able to prove that there was no feasible method of tying off. And that's very, very difficult to prove. Now, there are some exceptions that are right in the standard. One of them is for scaffold builders. During erection and dismantling of scaffold, they have a little more leeway because during erection and dismantling, there's very little to tie off to. But for most of us, if you're working from that scaffold, you don't have that provision. Does that answer your question?
It answered my question. I just wanted to make sure everybody understood that the exception to the rule is very, very difficult to prove. That it's not a scapegoat. It's very, very unique in its element, and it's something that you shouldn't lean on in that aspect.
Well, if we had a few more minutes, I could give you an example of very creative fall protection. All right, key points to remember from this presentation. First thing is recognize fall hazards. If you're not sure that what you're looking at is a fall hazard, ask somebody. Get a second opinion. You know, if you're not comfortable with it, then assume that it is and treat it as though it is. Okay, use fall protection systems, no matter which system you opt to use. Implement safe work practices. And part of that is making sure that people are trained that they have to put on a harness when that hazard exists. and it has to be worn correctly. Regularly inspect the fall protection systems. This is something that we run into all the time on stick-built construction, where fall protection such as guardrails in stairwells have been taken down because the drywall or the painter had to get in behind them and they were never put back up. Or window openings or door openings to an outside wall have been unguarded because they had to get something through the opening. So a regular inspection of the fall protection systems in place is very important. Protection from falling objects. When the potential exists, we either barricade the area below or provide falling object protection, such as a diaper under the lift to catch anything that's dropped from the lift, or overhead protection such as a canopy over the work area. If you've been into downtown Minneapolis or St. Paul, you've seen canopies that cover a whole block. And then keep in mind that having a rescue plan is a requirement for having anybody working in fall protection situations if the potential is there for an arrested fall. All right. Heather, if you're listening, now's the time. First line of defense when it comes to falls in the workplace. Control the
All right, everybody. Yep, your answers are control the fall itself once it occurs. B, eliminate the fall hazard completely. C, with the fall hazard present, prevent the fall. Or D, use personal protective equipment. We have about 40% who have voted. I'm looking for at least 70%. All right, there goes a few numbers. We've got about 55% that have voted. We'll give everyone about 10 more seconds to go ahead and submit their answers. 5 more seconds. We're at 62%. I know we can get to 70. All right, 3, 2, 1.
The answer is eliminate the fall hazard completely. That is the correct answer. All right. Second question.
Question number 2, what fall protection system prevents a worker from reaching an edge or a hole? A, personal fall arrest system, B, fall restraint system, or C, safety net? All right, we have about 50% who have voted. Give everyone about 10 more seconds to answer this question. All right, we're going to close it in 3, 2, 1.
Good answer. That is the correct answer. Fall restraint. Safety net, although we didn't discuss it, they're not used widely in much construction. You will see them in high-rise construction periodically, but you will see them in heavy civil work where they're working over water. You will commonly see them. For any of you that happen to see the work that they were doing on the new Stillwater Bridge, they had nets below the working level essentially through the entire course of that. But there are other requirements that come in there, so we're not even going to talk about that. So yes, it is fall restraint. And lastly, what are some ways to prevent items from falling from above?
All right, everyone, your answers are A, do not store materials close to the edge. B, keep areas barricaded. C, use screens or panels. D, keep tools and equipment picked up. Or E, all of the above. Great job, everyone. We already have about 65% who have voted, so I'll give everyone about 5 more seconds to get their answers in. We'll close the poll in 3, 2, 1.
Bingo, everybody got that one right. Nice, it is, in fact, all the above. All right. Go ahead, Tim.
Down. I want to thank everybody for attending. If Heather can wipe off or Dan can wipe out the poll results, that would be great.
Oh, Tim, if you just hit the X in the top
Got it.
left-hand corner.
If anybody has any questions or any future information that they would like from us, our contact information is on that last slide. Please get a hold of us and we'll be glad to meet with you one-on-one and answer any of your questions. Also, we did not get the slide up and we apologize for our future webinars, but we do put webinars on once a month. And if you're interested, we will be glad to send you information out. If you're on our mailing list, you'll receive that on a continuous basis. So thank you again. Thank you, Heather, for focusing and helping us make this work. And Dan, for your expertise and your presentation, thanks. If there's any final questions, please let us know by email, by chat, or by phone call.
All right, we do have a few questions coming in through the chat. I think we have a few minutes we can answer some of these. So one question is, can you tell us how many of the 31% in the second slide are roofing contractors?
Not without additional research, no. Yes, the numbers are available through the Bureau of Labor Statistics.
All right, thank you, Dan. The next question is, what defines secured in reference to opening covers?
To prevent accidental displacement. In other words, if I kick the edge of it, it's not going to slide off the hole.
All right, great. Thank you for that. And I know that we did get this answered, but I wanted to let everyone know one more time. We will have the slides, a PDF version available. If anyone's interested in getting that, you can either call the office or send us an email and we can get those out to you. Dan or Tim, do you have any final parting words for everyone?
No, I guess the only thing I would say is keep in mind that if you're going to be selecting systems and you're looking for additional resources on that, this is essentially an awareness level class on what you should be looking for to say, yes, I need fall protection systems. So if you need help in selecting systems or coming up with a rescue plan, that's what we're here for.
The only thing I'd like to add is if you are a general contractor and you're putting together your plan to submit to subcontractors to bid your project, or if you're a subcontractor bidding a project, make sure you put a lot of time and effort into looking at requirements, job functions, and job hazards within fall protection so that when your crews are on site, there's no surprises, because we see that often where we got on site and we didn't know we had to comply with this, or we didn't realize this was going to be a hazard out here. And either they avoid it and continue to work and put themselves at risk, or it really slows the process down and changes the entire structure of that job site. So put a lot of time and effort into evaluating before you put yourself and your people back on that job site.
All right, thank you both so much. And on behalf of OECS, we thank you for joining us and we will see you again next month. Please take a quick moment. There will be a survey that pops up in your browser and let us know how we did today. And we will see you again next month. Thank you so much.
Thanks, folks.